Hi everyone, welcome to another AP Statistics video. Today I'm going to start a discussion on probability, which I'm sure at this point of the year you've already covered fairly heavily, but I want to make sure going into the AP exam you understand it. And today specifically, I'm going to be talking about unions and intersections, and understanding what these are is vital to, first of all, writing probability statements and using those statements to solve probability questions on the AP exam. So let's get started. Grab my fancy pen here. Anyways, let's talk about what a union is. The union of A or B, which are essentially just two events or two situations or scenarios for a probability question, consists of all outcomes that are in at least one of the two events, that is, in event A or B or both. And here's an easy way, and you're going to be seeing this symbol a lot, right? But think of it this way. It looks like the letter U, right? And so U is for union. U is for union. Forgive the bad handwriting, but U is for union. So whenever you see this symbol, you think, hey, this is a union of A and B, so it can be in A or B or both. And here's a crummy example. I don't like it. You can look at it real quick. Yeah. But basically, all the events in A and all the events in B are being put together. So you can have one, the other, or both. U is for union. Remember that. The intersection of A and B consists of all the outcomes that are in both of these events. Now here's the key. Intersection in both. I can't stress that. When you see intersection, this symbol right here, which is, you're going to need to look at the place where they intersect, or where they both have something in common. And this symbol kind of looks like the letter N, right? So we can think the N is for intersection. Remember, U is for union, N is for intersection. So when you see this symbol, you must think intersection. N is for intersection. So I'm going to take an example to help kind of visually show you what an intersection would be. So let's say you have a dice, right? And you're going to roll it. And what's the probability of getting an even and prime number? Well, there's only one even and prime number on the dice, and that's number 2. You know, standard die, numbered 1 through 6. So let's look at a Venn diagram to represent this. And so we need something that is even, and here's where you have your evens. And here's where you have your primes. You know, the number 1 is a special number, so it does not belong in the even, obviously, nor does it belong in the prime number section. But hey, we need even and prime, right? So what kind is this? This is going to be an intersection question. So we're going to put a little upside down. We're going to put our little n there. And we need the intersection of both even and prime numbers, and that gives us the number 2, right? It's the only even and prime number on a dice. So that's a visual representation of an intersection. So we're going to, in the next minute, I'm going to show you some examples of probability statements, and I'm going to visually show you what they mean. So here's the setup. Some students are enrolled at a school. Some students are enrolled in statistics, calculus, and computer science, right? And on the next slides, I'm going to show you what this visually would look like. So here we have all of the computer science section and all of the calculus section. Notice how we aren't looking for just the students that are in computer science and calculus. We're not looking for the intersection. We're looking for all of the computer science and all of the calculus circles, right? So this is really the this is the union, right? Yes, the union of both the calculus and computer science classes. Let's try another. Here we have computer science as well as statistics, but none of the calculus. So here we're looking for students who are in computer science and in statistics, but not in calculus. Now look what we have here. We have students who are only in computer science and statistics, and not anything else. And here and look at this statement, statistics and not in computer science or calculus. So if we can break this statement down, let's just look at the first part. Computer science or calculus. So we're just looking for the union of computer science and calculus. I mean, that would be all of this, right? We have the union of computer science and calculus would be all of the calculus circle and all of computer science, because we would need all the students in either computer science or calculus. That would be the union. But we want not in computer science and calculus, so we would take all of this area away, leaving only the statistics students behind. That's why this circle represents the students who are, this shaded area, the blue shaded area, represents only the students who are in statistics. Alright, I hope this gave you a more visual understanding of what, probability and situation statements mean. Remember, U is for union, which is either or both, and N is for intersection, which is one and the other. In the next video, I'll talk more about more complex probability statements and situations, and hopefully y'all join me for that. Thank you. Look to see you soon.